All right, to find the absolute extrema of the function, we need to figure out where the critical numbers are, which means finding the derivative. So go ahead and find the derivative of our function. And then I can look at that and see that that will never be a does not exist. That will always exist because it's just a regular polynomial. It's a cubic function. But it can equal 0. So then I'm going to take that derivative and I'm going to set it equal to 0 and then solve it out from there. And we find that x equals -1. All right, so I now know 3 numbers that I'm going to need to check when checking for where the extrema are. So I'm going to have to figure out now what is f of -1 that I just found, the critical number, and I need to do the same thing for each of the endpoints. So I need to figure out what's f of -2 and what is f of 0. One little side note before I go on. Notice that the -1 is inside of my interval. Always make sure you check that. If this had been a -3, I wouldn't need to check it because it wouldn't be in the interval that we're supposed to be looking at. And sometimes you will see that happen. All right, so I'm going to take each of these numbers now, plug them back into the original function. And now that I have my y values, I can just look to see which ones are the highest and the lowest. So my minimum value, that would be my smallest y, so that's the -3. So that's going to be at the point -1, -3 for my minimum. And then my maximum comes with wherever I see the highest y value, so that's the 8. So that point is going to be at -2, 8. And those are our absolute extrema.